I'm Anil Kumar. In this particular video, we'll discuss how to prove cofunction identity. We have two examples here. Prove each of the following. A. Cos 3 pi by 2 plus x equals to sin x, and minus tan minus x minus pi equals to tan x. So we'll begin with cos 3 pi by 2 plus x. Let me show you the situation first. We are going to compare with angle x in quadrant 1. Let us say there is a point P here, AB, right? So in that case, what we know here is that this length along the x-axis is A, the length along the y-axis is B, and R, let it be the length of OP. We are going to consider the argument 3 pi by 2 plus x. That means the rotation here is 3 pi by 2 and then plus x. It's kind of like this. Now in this particular situation, the angle is 3 pi by 2 plus x. You can see that the point P dash, A has become B and B has become A, right? So it's kind of BA, where since it is towards minus y, it's minus A. And from here, these triangles clearly indicate that cos of 3 pi by 2 plus x is sin x. In quadrant 4, cos is positive, right? We know the cos rule. That is to say, all are positive in quadrant 1, sin in 2, tan in 3, and cos is in 4. And therefore, we got positive result. So, that is one way to explain. However, we are going to use the compound angle formula, which is cos A plus B equals to cos A cos B minus sin A sin B to prove this particular cofunction identity. So A here is 3 pi by 2. So let's write down cos 3 pi by 2 plus x, B is x. So that should be equal to cos of 3 pi by 2 times cos of x minus sine of 3 pi by 2 times sine of x. Now from the graph, let me sketch both the graphs here. The sine function is like this, right? And the cosine function is kind of like this. So this is the sine function, that is the cosine function. For 3 pi by 2, that's the position. For cos x is minus 1. And for sin x is minus 1. For cos x is 0. So we'll substitute those values. Cos 3 pi by 2 is 0. This is 3 pi by 2. And that is 3 pi by 2, right? Times cos x minus sine 3 pi by 2 is minus 1 times sin x. So what we get here is 0 plus sin x, which is equal to sin x. Clear? So that is how, using the formula, you can easily prove this identity. Now on the next page, we'll take up minus tan minus x minus pi. So here we have to prove that minus tan minus x minus pi equals to tan x. Let us understand few things. One, what is tan of minus theta equals to? Tan of minus theta is minus tan theta. It's an odd function, right? Okay, so we'll use this concept, and then we can rewrite also and work it out. But that is important to understand. Okay. Now, So we could write this as, let's write down. So we have minus tan minus x minus pi. I could write this as minus tan within brackets. Taking minus common, we get x plus pi. Since tan of minus theta is minus tan theta, we could write this as minus of minus tan theta here is x plus pi. Is it okay? And minus minus becomes positive. So we're looking for positive tan. Let me write this as pi plus x, one and the same thing, right? So if you look at the position, if this is the position for x, in that case, pi plus x will be right here, right? So this is pi plus x. Since you are in quadrant 3, tan is positive, right? You know, all are positive here, sine, tan, and cosine. So we are expecting a positive value. Now this is a related angle, and therefore the function should be equal to tan x, right? But let us use the compound angle formula to prove, right? So let us prove it. To prove, we'll use the compound angle formula, which is, let me rewrite the compound angle formula here, which is tan A plus B equals to tan A plus tan B divided by 1 minus tan A tan B. So we could write tan of pi plus x as equals to tan pi plus tan x over 1 minus tan pi tan x. Now, as you know, tan pi is 0. So we get 0 plus tan x over 1 minus 0 times tan x. Now that clearly is equal to tan x over 1, which is tan x, which is the right side, correct? So you could use compound angle formula straight to prove this particular cofunction identity. I hope it's clear. Thanks for watching and all the best.